Hello everyone and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is a series of episodes where we are creating a programming language from scratch using modernish C++, a terminal window, Vim is our text editor, and basic tools, or fundamental tools I should say, not basic, but fundamental tools such as Flex, Bison, ICU, and Google Test. And we have been going through, I think this is episode 97, and I don't remember what number it showed. And we are working on reducing the number of objects that we are creating and destroying. And we found a way of doing that in the previous episode, and now we're going to continue applying it because it's a technique that we can apply to a lot of our opcodes. And let's see, what do we need to do? We need to go to this here. Let's make clean. Make test watch so that we know that we're on a clean compilation, whatever. Anyway, and then get log. The very last compile was, or the very last commit was the end of the previous episode, number 96. And if I say get status, the only thing that's there are these call grind outputs that are from the previous. They're not part of the repository. In other words, no code has been written since the previous episode, and I've said this multiple times, nothing is up my sleeves. I don't have anything hidden. I'm not copying the code or anything like that. We are creating this from scratch. That means you see all of my mistakes, all of my thinking through, all of my syntax errors. I'm not copying and pasting. I'm solving the problem live. What problem am I solving right this moment? The little pin in my watch has come unscrewed, so I'm using my fingernail to screw it back in while I'm talking to you. Yes, that's right, the magic of editing. I didn't do any editing. So what we're going to do is, for that matter, this is finishing compiling on the right-hand side. There, now I can move my arm and that not scratch my arm. On the left-hand side, we know that we're going to, let's edit a test just so that we can see it. And let's do our program execute. All right, so that's the test. Here's the program execute. And notice we've got a couple macros here that we don't have help text for, but we should write it. We've got this print command for S and I, the cast, and the unary op. Yeah. All right. So the binary op, well, these right here, binary op SS. That one, binary op, whoops, there, binary op SI, binary op IS, and binary op II. These are what we wrote last time, and what we did is we realized that, for example, in the SS, we could get a reference to right-hand side and left-hand side. Before, we would copy it and then pop it off, and then do that for 2, and then compute something new and then push that back, push that onto the stack. Well, what we're doing now is we're saying let's just grab references to it, replace the top minus 2 with whatever expression is passed in, left hand side plus right hand side, whatever, and then just remove the topmost one because that's the one we don't need. So rather than popping 2 and pushing 1, or rather, let me back up. Rather than copying 2, popping 2, computing something and pushing that, now we're just getting references to 2. That's not a copy, that's just getting a reference to it. Computing the answer, replacing one of them, and then popping the unused one. And that is what we did for all of these. Now we're going to do the exact same thing, but this time for the unary op S, and I guess we need to pass in expression, and unary op I that will also need an expression. And what will this look like? So who uses a unary op s? Unary op, there we go. Well, here's one. And we've got operand. Yeah, operand, not. Okay, so we may only use this in 4 places. Hopefully that means we can write this quickly. So what we may be able to do is just say auto ampersand operand is equal to that, and now stack.back is equal to expression. Yeah, okay, so we're reusing what's on the stack. And okay, that will actually do it. How about this one? We can grab a copy of, oh no, wait, the index is that. We've got to check the index. That's correct. And then the operand is the stack of that. And now we need to stack dot, and I'm going to scroll down to see what did I do in the II here. And place back. There we go. Just grabbed it. Of expression. Yeah. Is it that simple? I feel like I'm missing something. So, I mean, there are fewer of these. Are there any others? Okay, so get iterator SI. Okay, so we cannot use get iterator SI. I mean, get iterator SI and II are the only two, and there, yeah. We need the original unary op, kind of. But it's really a unary op SI and unary op II. Maybe I can do that. Can I do that? SI and II. And what would we feed into it? We would feed into it operand. Yeah. That's what it should be. I'm just putting a space there. And we will call this PC plus equals 2 because that's what it's going to be now. So unary op SI, that's what we need. Let's go to unary op S. And call this one unary op SI. Okay. There, unary op SI. All right, now let's clean this up, shall we? We can't do the stack check. We know that Oh, no, wait, we can. But we also need the program check. Okay, the position is going to be that, and we can stack check the position, and we don't need to stack check 1 because position is going to be something. All right. Should it actually be position +1? I think it should be, which means there's probably a few other of these that we need to stack check something. Let's just scroll up. Okay, wait, what line is that? 88. So stack check is FP plus X. Yeah, so it should be that +1. Okay, we're going to need to double check that we're doing that correctly in other places as well. Operand is the stack back. That's fine. And then stack back is the expression. Is that right? Wait. Get iterator SI by 3. Yeah. But we're writing that. Okay, so I think we need that's supposed to go for the stack. So I don't think, okay. Now, shouldn't we be getting rid of that because we're consuming it? So, okay, so what are we doing? We're saying make sure that there's one more bytecode, get the position, and make sure that that exists in the stack, position +1. Now, the operand is whatever's on the back of the stack. Set the value, FP plus position. No, wait. I was wrong. I don't need a +1 there. I've been doing it right this entire time. Because we're checking that FP plus position is there. So if position is 0, it will be writing to FP plus 0, and it's checking for FP plus 0. So, okay, we're good there. And now we're popping it and going about our merry way. Yeah, that should be right. That means I can get rid of all of that. And now we've got unary op II. That's going to be very similar. SSI, here is I, and we need II. II, okay. Now it was going to do all the same stuff, except we need to grab 7 there, okay. We'll fix all of the ending lines. This should be +3, delete that. Okay, so what are we doing? We should be doing an execute program check of 2, right? Indexes that operand is so this is the new stuff down here. Yeah, program check of 2. The position is bytecode +2. And position we're pushing that onto the back, which that's the in-place back. That's fine. Wait. Should that leave... Should that leave a copy on the stack? Unary op II. Okay, execute program check of 2, and we get index and position. We make sure that they both exist on the stack, and then we operand is fp plus index. That's fine, and then we write that to position, but we're putting it on the top of the stack as well. Is that what's supposed to happen? We were putting it... Oh, we were calling getIterator twice. That's kind of silly. All right, what's it not liking? Unary op I for is iterator end. Okay, everything's passing. It's always a good thing. Now, what about this here? Iterator next. We get the next. The target. Oh, so this doesn't push it onto the stack. Okay. I'm worried about get iterator II. And maybe even SI should not be leaving something on the stack. We're going to look at that in just a moment. But for this one, I mean, that's all correct. It's just not leaving it on the stack, and the only question is whether or not the others should be leaving it on the stack. So let's go to our test. And what would this be? Ranged. The ranged 4. Let's just see out P1 bytecode. I mean, all of our tests are passing. That's usually good. So get iterator II, in my opinion, should not leave something on the stack. Because iterators now, the way we've written this, are always In fact, will we ever do SI? Yes. GetIterator could be SI, but iterator next is only ever going to be II. And isIteratorEnd is only ever going to be an I. And I think that that's correct. If I look at edit include opcode, GetIterator, yes. To a stack index. Supplied index to calculate the next value, then store. Okay. At the stack. And isIteratorEnd will push the result. That makes sense because the next one is usually a jump. But iterator next should not push anything because it's never going to get popped. Wait. Yeah, that is correct. Okay, so GetIterator SI, don't push. GetIterator II, don't push. GetIterator II, don't push. Iterator next, don't push. isIteratorEnd, push. So this is calling unary op I, and it should push because it will push, yes. But unary op SI and unary op II. In this case, okay, so instead of calling them unary op, SSI, II, SI, those should all push. That's fine. But this should not. So I think instead of calling it unary op SI, I'm going to call it iterator op. Iterator op II. Okay, because they should not push. There. It's no longer going to push, it's just writing. Okay, so iterator op, we're going to, and yes, since we're coming up with these rules, we're going to go ahead and write our help text. So this is unary op S. To stack And that is going to be to evaluate. Okay. I'm going to turn my phone off silent because I'm waiting for a call, and I think I just missed it, but we'll see. If I have to pause really quickly, that's what's happening. So unary op s, it is a is pushed to the top of the stack. Okay. Operation is, which the operand is from an index location within the stack. FP. Is pushed to the top of the stack. That's fine. See if this is behaving. Hit save. All right, and of course I could get rid of this here. What do I want to do here? I think just delete that. Then this should give me a good space, a good place to say get status, get diff, and so unary op s, unary op I, iterator op. Yes. No, wait, does that mean that the iterator next I can be Did we say that that needed to be... Yeah, it doesn't push it onto the stack. So, iterator next, II, doesn't push it onto the stack. Or iterator op, II. Yeah, so we can... yeah. So operand is what it's calling it. So iterator next. And there. There. Iterator. Okay. Evidently I just misread a word and typed a lot more than I needed to. Everything's passing. Good. Okay, so now to and iterator. Opcodes. Okay. Let's go back. And I want to check out, so we've got this unary op now. Binary, we need to do the documentation for that, but the cast op and print op. So the print op, what's the difference? Expression, it's what word we used. Yeah, I think those are about to... So instead of cast op and pushing back, I think it's going to be called unary op. Yep. This is going to be just globally change cast op to unary op. All right, now for these, unary op, okay. And now we got to go back up to the top because we have now this unary op s and unary op I that need to go away. So those are now deleted. See if this works. It does. Okay, that's good. That's good. No. There. All right. Let's go in again. Why? Because I bet the print op s, look, it just uses expression. It can probably be, I just want to find it. Oh, okay, wait. So print op s and print op I are special because it's what has to happen afterwards. So let's do this. I don't want to have these macros for only one use. So this is the print op s one. Okay, so okay, now what are we doing? So we're getting expression is equal to stack back. We're trying to, we get the result, try to convert it, or expression, try to convert it to a string. Get the result. If it is a string, then Oh yeah, I see what we're doing. And now we don't need to, we can say stack dot back equals because we've already got something. Yeah. Well, expression is equal to stack dot back. So can we just say expression is equal to? I'll leave it as stack dot back for the moment. All right, so this is, so with the S, there is something on the stack that we're not getting rid of, we're just replacing. Okay. As opposed to the print I, which should be there. Okay, so what all does this do? Index is that. Stack check the index. Okay. Here I did, yeah, I did get rid of the thing. Okay. So the result is we call expression string. That's fine. Instead of push, let's do in place back. Oh, that's in the, that's past the, oh well, that's fine. This is wrong though. It shouldn't be stack.size. It should be bytecode, right? Didn't I already, I fixed that another time? Oh, I think that's when I was trying to turn them into the tail call optimized things. All right, so now print I can do away with these 12. Hopefully this works. Okay. It's working. So that means everything's printing. Let's see. Is that the SI optimization? Well. How about clean up? All right, I think that's good. Let's just do this. Binary operation macro in which the LHS and the result is all right. We just now need to apply this to these three and fix the wording. In which the right-hand side is read from an index position within the stack fp plus RHS index followed by the left-hand side from the top of the stack. LHS is removed from the stack. The expression is evaluated and the result is pushed onto the stack. Okay, that's fine. In which the right-hand side is read from the top of the stack. And the LHS is read from an index position within the stack. And we'll say FP plus LHS index. How many words is that? Both are removed. No, not both, but RHS is removed from the stack. The expression is executed and the result is pushed onto the stack. That's fine. Now for the last one, in which LHS and RHS are read from index positions within the stack. FP plus LHS index and FP plus RHS index respectively. There. They're not removed from the stack because they're not on the stack. Okay, the expression is executed. All right, normally, and this is just me, I'm going to put an extra line in between each one of these, just for readability's sake. Maybe it's my Python background in which you usually put 2 lines after a function, but that's okay. There. This does not add to our line count, of course, right, with the tool that we're using. It's just a helper function, so I'm not writing documentation for that. Let's see where we are. Make sure I haven't broken anything. Somebody said hi in the Twitch chat. Hi. Make sure that the only thing we've done here is to opcode execution macros. All right. And let's go back one last time. And so we've got everything written out for these values. Of course, we hope there's a faster way of executing the functions. We'll worry about that in a moment. But for right now, okay. So what about our opcodes? so I can, so peek, I'm not seeing anything that I can necessarily do here. We just push back or copying. Poke is a copy. Copy. Let's see. As we're putting it, okay, that's fine. The jump, very straightforward. Jump if false. Without a pop. Yeah. Ampersand condition on that one, so everything is fine there. Jump if false pop. Oh, this one. This is a copy, but we could do an ampersand there and move the pop there. That way, it's not a copy, and it is just, yeah, it's no longer copying it into condition, and we, you know what? We could even be better. We could say PC is equal to stack back equals false. If so, a PC plus 1, else PC plus 2. And get rid of all of that, get rid of condition. And we can probably do this same sort of thing here. So instead of condition, there, no, we don't need condition at all. What about this one? Basically the same thing. Oh. Jump true S. There. Jump TI. That's fine. Jump T pop. And instead of false, that should be true. All right, let's save that and make sure everything is still working. It is. I'm wondering if a lot of these pushbacks could be an in-place back. So for creating the array, this could be faster. Because we're basically pushing back, but we could just use iterators. I need to... Let me add this as a to-do. To-do. Or are they in reverse order? Well, there. Put that there. Map, again, just looking to see if there's anything. So this is causing a copy. So let's do... -2. All right. Save it, make sure all the tests are passing. All the tests are still passing. That's good. What about library? The name is here. That's a copy. So again, this is a name. Yeah. So we don't have to do that. We can say else stack dot back is equal to that. Let's see if that still compiles. Oh. All right. So that was the library. How about library save? Index stack back. Okay, so we're not copying there. Well, how about library copy? Back. Okay, so that's loading the library. That's fine. Okay. Assign index. Oh, we haven't done our assigns. Index stack back, collection stack back. Oh boy. And we're pushing back that. Okay, so now we're going to do top minus 1 top minus 2 top minus 3. And now we'll say top minus 3 is equal to that, and then just remove the other two. Can I say so C++ vector reference, can I just resize it to size minus 2? Or is there a, no, there's a shrink to fit, but that's not what I want. Resize, yep, top minus 2. doesn't like that. Okay. Sack.back. Okay, yeah, that would be why. I'm not sure where the error is. I mean, it's because of something. Oh, wait. 584. It doesn't like a resize. All right. That's fine. I'll just leave it as 2 popbacks. And fix that again. I've got another change that I'm wanting to do in the future that should make that problem go away. Everything is still running. All of these that we've already optimized, that's a lot. The period, okay, we're using ampersands where you've got a temp. That's fine. Hopping back and then setting the back to equal temp. That's fine. Period SI. This is going to be the same basically. IS, II, indexing. Okay, we're using our binary op stuff. That's good. Slicing, we have not optimized this. It's going to take, what? Oh, stack check 4. Yeah, there's 4 parts to it. So that means there's 16 potential opcodes. We'll save that for a very rainy day. SI, II. Oh, these are the iterator ops. That's fine. The casting, we got that. Call func. Okay, what about this? Oh, and call func I. Call func should probably be call func S. Yes. It's going to have one thing, and this one's going to have 2. Okay. Is there a way around this? No, because when we call the function, yeah, the function has been put on the stack, and we have to remove it so that when we call the function, it's no longer on the stack. So I don't see a way around this particular case. Okay, keep going, call func I. We're using an ampersand because we don't want to copy it, so this all seems correct. Okay, how about the return? So the only thing I could do here is on the return val, I could say pop minus. I could say less than pop. To the FP plus 1. Why? Because now we can say stack dot back is equal to return val. Yeah. Make sure everything still works. In the meantime, I'll be looking at print S. I'm assuming that it's going to work. It is working. Okay. Expression is equal to stack back. The result. And then we're replacing it. Yep, I wrote this earlier today. Okay, and I wrote it with print I as well. And then the default. And this is indeed a copy. It needs to be because then we're clearing the stack. And that's fine as well. Okay. I think we can see we only got a couple of things left because that's, I mean, where we removed a copy or something, but gonna have to look at that one. All right. Okay. I think at this point we're going to update our documentation. So make docs PDF. And on the right hand side, let's just run this again. So that with a clean compile, we're sure that everything's still compiling and all of our tests are passing. All right, and on the left-hand side, yeah. episode 90, I think 7, is that right? Before we, episode 97. Oh, I didn't say test. I'm waiting to hit enter on pushing it to make sure. Did all the tests pass? Yes, they did. Okay. Zero 097. Can't type numbers. 6 and 7 are really hard for me for some reason. I don't know why. All right, and we are at a good stopping place. Still around 12,500 lines. We've been hovering around that lately, but that's where we've been doing the major part of our work. 3,800 lines of comments. All right, and yeah. So where does this put us? On the right-hand side, if I say make test, do that a couple times, we'll see that we're still hovering between 4 and 5 milliseconds. Oh, 6. Well, that's within, I think, the margin of error for this. I know that we are producing better code. It's just we're not exercising it that much. So it's like, well, is it worth the effort? Yes, it is. There's something, even if it's just mental, about doing it the right way. But still, our biggest speed increase is going to be, I think, getting rid of the singleton object pool, and maybe, instead of using, and I can't believe I'm saying this, I did all of this work so that we could have a garbage collected container that doesn't worry about what am I trying to say? Doesn't worry about whether or not there is a it's not thread safe, intentionally so, because we're only using it in one thread at a time. Maybe the solution is to switch to a shared pointer, and that might be faster. And I don't like having to admit that. So that's it's like, did I miss something? Sorry, phone. Remember, I'm expecting a phone call. Yeah, well, okay. We're in a good stopping point right now, and I will ponder the future of whether or not we should use computed expressions. Whether or not we should use the garbage collected container or shared pointers. That may be an experiment coming up rather quickly. Until then, thank you again, and hope you're having a great day, and hope this was of a benefit to you. So thank you. Bye.